Hey folks, so I would be talking about a new system design today, a system design for LeetCode. Um, I think this is my fifth video in the system design series, and as in the previous system designs, I want to add a disclaimer first. So the system design I would be talking about is kind of an inspiration from this particular blog and the corresponding uh, video. So I have been using I have been using Hello Interview to brush up my system design skills. And this particular system design video, as the other preceding four different system design videos, is kind of a product of that upskilling. So without further ado, let's get started. So in order to get started, the first thing we need to do is come up with a set of functional and non-functional requirements. And let's start with the functional requirements for LeetCode. So the first requirement is that user should be able to view all the problems with certain filters. For example, the user might want to view all the problems which are corresponding to a typical type of data structure, or they might want to look into a certain difficulty level, or a combination of both. So that would be our first requirement. User should be able to view problems with certain filters added, with certain filters. Second, user, once a particular problem has been selected, the user should be able to click on that problem and view the details of the problem. So user should be able to view a particular problem in detail. The third would be, if the user has once the user has looked at the problem, they should be also able to submit a solution in the language of their choice, provided that that language is supported by our system. So user should be able to submit a solution to a problem and get immediate feedback, whether like working, success or failure. And the fourth would be, in the case of competition, the user should be able to look at the leaderboard and figure out who is at what position in the leaderboard. So in competition, the user should be able to check the leaderboard. Okay, so these are our functional requirements. Now let's look at some out of scope functional requirements. So the first would be that you're not going to help with payment services. So that is one. Then what else we're not going to allow to the user? Yeah, okay, cool. So that is it. I'm not able to recall anything else at the moment, but if something comes up, then I will add for sure. Now let's move on to non-functional requirements. These are pretty critical. The first non-functional requirement is that whenever we are running a code given by the user, it should be we should be running it in a way that it does not compromise the system. So some kind of isolation, some kind of security while running a code. So isolation, run the code in an isolated environment to ensure security, in the sense that a malicious user should not be able to push some code to our system which runs havoc, creates havoc. So that is point number one. Second, support a peak of 100,000 users during, let's say, competitions, without competitions as well, but yeah. The third would be, we are going to ensure availability more than consistency, in the sense that if I open LeetCode or my code judge kind of platform, it should always be available, though it is possible that when I submit a particular solution, it is not immediately available to a user who is looking at the solutions of the same problem in a different continent. So what I'm trying to say is, let's say I submit a solution for BFS or DFS, and the same question is being perused by a user in, let's say, Germany. Then it is okay if the user does not see my solution in real time. There might be a lag, that is fine. So availability is greater than consistency. What else? So we have talked about security and isolation, we have talked about support, we have talked about availability greater than consistency. That is what is coming to my mind right now. Again, if something else comes to my mind, I will add later. What out of scope, we are not, obviously, I mean, login is kind of expected, so we are not going to support login features. Similarly, CI/CD features, these are kind of common features which are obviously a part of all the tech solutions in the current world. So we are not going to support them. Cool. So that is it. Now let's talk about some core entities. I'm not going to talk about the detailed schema of these tables or these entities, but some sense of entities, like what exactly I'm going to deal with, is helpful. Cool. So let's move on to core entities now. So the first would be obviously the problems. What exactly the problem means, and there would be certain metadata. For example, let's say the data structure or the difficulty level or whatnot, success rate, that could be another. So we'll have a core entity with problems. By the way, test cases might be a part of this particular entity, or they might be a different table. That depends upon what kind of database are we going to use. Anyway, so we have problems, then we have solution. User would want to submit a solution, and this would be that. Third would be leaderboard. Fourth would be user, which okay is fine. What else? So we are doing the problems, particular problem, submit a solution, leaderboard. Okay, cool, this is fine. And now let's move on to the API endpoints. So in order to define API endpoints, let's go to our function requirement one by one and make sure that an API is satisfying that requirement. So the first is you should be able to view the problems. So we'll have a get API endpoint, which is, let's say, /problems, and there would be, as mentioned here, that's a couple of filters. We'll have a couple of parameters here. So let's say level equals to this, and category, which could talk about the data structure or whatever, could be here. And then we would have, let's say, page. So we are going to add pagination here. LeetCode has somewhere around 3200 to 4000 problems in all. So we need to understand which set of problems, which page, how many problems we are going to furnish to the user at any given point in time. So yeah, we have page number 1, and items equals to, let's say, 100, and there could be other parameters as well if required. Okay, now second would be okay, by the way, okay, that's fine, I'll come back to that later. Now once we have a set of problems we want to look at, so yeah, what will this return? This will return a set of problems, a list of problems, and we're not going to give solutions here. We're not going to give anything important. So okay, that's fine. Now we will have another get request for a specific problem with a given ID. So we have problems /ID, which could be problem ID, and also, yeah, that's it. So again, this will give you the problem in detail. It will not give you test cases, because test cases are not required for the user to understand. There would be a blob, there would be some example test cases where what kind of situation fails, what kind of examples the what kinds of inputs, some examples for what kind of input the problem is taking, and then correspondingly what some example outputs. But overall, let's say the problem has 100 test cases or 1500 test cases, whatever, because in LeetCode at least a lot of people contribute test cases. So the test cases will not be a part of this particular return object. However, the languages supported would be a type of this problem object. But again, we'll define that later once we come to those details. So we will be returning a problem object here. Now, once the user has looked into the problem, the user will want to submit a solution as well. So we'll have a post request, which will be to solution, and this is where what I wanted to talk about in a bit detail. So we'll have this. We will not be passing user ID in plain JSON. This would be taken from JWT token. Which is a common practice across different APIs to ensure some kind of security. So this is the user ID is coming from JWT token or security token, session token. Now the other parameters would be problem ID equals to problem ID. Then there would be let's say the language in which the user has coded. So this would be an enum kind of thing, whatever problems are supported, whatever language is supported for that problem, and overall in general on our platform. Is there anything else you would want to add? And of course there would be the solution itself, which would be a text string kind of a thing. So this would be string thing, and that's it. So that is our third API, and the fourth API is around the leaderboard. We want to understand who is ranking at what place in any competition, whether ongoing competition or a past competition. So we will have another GET request which is for leaderboard, and this will take let's say competition ID. Cool. So these are all API endpoints. We have code entities defined, and now we can start with the actual fluff of the system, which is the system design. Now let's start with the user machine, which is user browser, and they will make a GET request to an API gateway for some I know a bit about AWS, so I'll be using an AWS API managed API gateway, but there are other solutions from other cloud providers as well. AWS, we have API gateway. This does a couple of things for us. It does the load balancing part, it does authentication, it does rate limiting, and so on and so forth. Excuse me. Okay, now there are multiple ways in the system design. We can use microservice architecture, or we can use monolithic architecture. Earlier, even now as well, microservice architecture is very commonly used, but in this system we necessarily do not want to go that route, primarily because this is a fairly simple solution. We will not have a lot of moving parts here and there. So let's go with the microservice architecture, though we will have a worker down the line where we will run the code. So okay, so now this particular request, so we are doing a GET request here, get problems. This is or rather let's do like this, get/problems, and let me move this thing here. So there will be multiple API calls done to the same API server. They would obviously be horizontally scaled, but we'll come back to that in a while. So this is our API server. There's only one server, and then we will have a database, which is a problem database, or just the database. There will be different tables here. Now we can use any kind of let me just talk about this 1 second. LeetCode DB. Yeah, so now there are different solutions we could be using for storing the data. We could use a NoSQL database, or we could use also SQL database. In the diagram which I showed you, sorry, the article which I showed you earlier by Hello Interview, the author, his name is Ivan. He has used a NoSQL database, but I think a SQL database would be more useful here. But we could use any of these, so that is not a concern. I just myself am a bit more comfortable with using SQL here, because there are multiple tables which we would want to have, and I would rather have those tables separate and have foreign key relations between them. In the design which is shared by Ivan, he has nested entities, so that depends upon the choice you want to make. Both of them will work. So okay, let me talk about what exactly we are going to query here. And yeah, so we have fetch problems, and of course there would be certain parameters which I'm not adding here, but they would be obviously a part and parcel of this. Okay, so the LeetCode database will have, this is, let's say, a Postgres SQL database, and we will have multiple tables. Let me start with the first table to begin with, which will have a problem database. This will have ID, this will have category, let's say, so category is let's say DS, what kind of DS we are using, what kind of algo we are using. Then there would be difficulty level. They could be a best solution kind of thing, or we can have a separate table. Actually, we will have separate tables. Let's just have it there. Then we have languages supported. Okay, and then there could be other details which I am not talking about right now, but this should suffice. With problem, we will have another. So let's say we will have a bunch of test cases as well, and we can have them here. There's no specific reason to have a different test cases table. Now, for different languages, there will be different test cases, and I'll come to that in a while, how we are going to handle this particular situation. But there would be a set of, or an array of test cases for this particular problem. Now we have problem, and I would want to talk about solutions as well, but I'll come to that once a user posts a solution for a given problem. So that is it for now. Now this particular database gives back the problems, fetch problems, and the user has all the problems. Now the user clicks on a particular problem. So now the user would want to look at a particular problem again. So problem slash ID, and now we will do another request to the same database to get the details of that problem. So fetch problem details, and then we will pass an ID to the query. 1 second. Yeah. Okay. So we have a query on API server, and then we make another request here. So fetch problem details with the ID. We give back the problem details, and the user has those details. Okay, so the user has those details. The user looks at all the problem, the entirety of the problem. He or she understands the problem. They code the problem out. And by the way, there are different ways how we can enable coding at the client side. One particular solution, which is a lightweight web-based solution, is Monaco editor, which is the core of Visual Studio Code. It is provided by Microsoft, and that is what we would be using. So this could be embedded in your on your website, and that will allow the user to submit solutions then and there on the web itself. So now the user has coded out the solution, and they want to give back the submit the solution in the first place. This is where we will do a post request to submit / problem ID. I maybe should have, let us do this actually. Yeah, this is better. Now we will have another table in the database, which is your solution table. This would have few fields like there would be one obviously ID, then there would be problem ID, then there would be language, then there would be user ID. Then though not right now, but we will populate this particular field once the code has been run, which the field would be status. The status could be running or success or failure. Okay. What else? That is, then there would be test case. There would be test case status. So we would want to understand which particular test cases failed, which particular passed, how many failed, how many passed. All those kind of details would be a part of the solution. And because in a case where, in a scenario where the solution failed, the submission failed. So by the way, this is submission, not solution. My bad. Submission, because solution implicitly means that it has been solved, the problem has been solved, wherever the user might not have solved the problem in the first place. There might be 5 test cases failing out of 100, whatever. So there would be a situation where, let's say, 5 test cases of 100 failed, and we would want to communicate back to the user that these are the test cases which failed. And we can also give the user a comprehensive guide of, comprehensive list of some kind of details which will help him or her understand which test cases failed and which are the edge cases they did not think about while coding this thing. So, and then there would be other metadata which, if anything important, I will come back and update this table. So we have the solution table, and now is the interesting part, like how do we run this particular solution here. There are a couple of solutions, there are a couple of approaches. The first approach is, so the requirement we are going to solve right now is the third one, that the user has submitted a solution and should get immediate feedback. Now the immediate feedback part, run a solution in the server at the backend. Now there are a couple of approaches, as I was talking about. The first approach, which we would not be using, is run the solution on the web server itself. There are a couple of problems with the solution. First is that we are exposing our machine to unknown code. It is possible that this particular code, which is being given by a user, from a novice point of view, it could have an infinite loop, or it could be there could be a memory leak, or there could be a number of other a novice mistakes which the user could do. So in that particular case, some honest mistakes will bring our server down. So that is point number one. Honest mistakes bring server down. Second thing is, let's say there are no honest mistakes and there is a malicious user, a kind of a hacker, who wants to bring our system down. There are n number of attacks going on throughout. So someone could push a malicious code and bring our server down. That is other problem. But not only that, though we are not talking about user details, we're not talking about payment details, but a hacker could also get access to the database through if we are running the machine, the code in our API server itself, and then they could get access to that data. So we do not want to do that as well. So it's not only about bringing our services down, they could also steal our data. So that's the reason, these are few reasons why we are not going to use our own API machine to run API server to run this code in the bare format. Now the other solution is we can use a VM. A VM is a virtual machine which is kind of a node server running inside a particular server. So a machine running inside a machine. This is a okay solution in the sense that there is a separation of concern. Whenever we will run that particular code inside a VM, it would be completely, the VM works completely different from the host environment, in the sense that there's a completely new kernel, there's a completely new OS, and the resources are shared, resources as in like RAM and CPU, but there is no way a code running on the VM can access the host. So this is a good solution. The downside of this solution is that VM is very heavy. Whenever you run a VM on any machine, it takes a lot of time. First of all, it takes a lot of time to boot up because you are starting the OS itself, and secondly, it also uses a lot of resources because you are actually running an OS inside an OS. So the problem with this is works works in the sense that separation, code runs separately, but very heavy, uses a lot of resources, takes time to boot up. And the other thing is that it's not that we will be we can just run a VM once and then we can use it over the period of time. For every submission we will need to start a new VM, which is again going to be a lot of time taking. So a new process for each submission, and this will not work. I mean, it's an okay solution but not a great solution, and that is why we will use containers. So for example, Dockers. So Docker, the difference between a Docker and a VM is that Docker is much lightweight and it does not necessarily need to start with the base OS. For example, if I'm running this thing on Mac, then I can use a kernel based, in the sense like a Linux based, a Unix based machine, a Unix based OS to create a Docker. If I want to create a Docker on Windows machine, then I'll have to create a Docker on a Windows machine, because it takes it runs on the underlying OS of the machine itself. So that is why it is lightweight. So we will using Docker for this, and then we can have different containers supporting different virtual environments, supporting different runtime environments. So we can have a container for Java, we can have a container for JavaScript, we can have a container for Python, we can have a container for .NET, any of the languages you want to support. Starting a container, starting a Docker is not that difficult, is not that big a challenge. It is comparatively faster, much faster as compared to your VM. So a Docker is a reasonable choice here. So different runtime environments for different languages. Okay, so let me draw this. And there are two ways again to talk about this. One is that we run all these containers in the API server itself. That is one solution. The other solution is that we can have a worker or a set of workers who are running these Docker containers. So right now we can have a Docker inside the API server itself, but as we go into deep dive, we will remove this and have some kind of separation of concerns here. So for now, I am just adding the container run submission on containers on the server itself. So yeah, so now not solution, submission. Cool. So this particular system as of now takes care of our functional requirements. Oh sorry, there was one more thing, which is our the user should be able to check the leaderboard. So this is again comparatively easy. For now, what we will do is we will do a GET request on leaderboard with a comp ID. By the way, first of all, what exactly is a competition? That is something we need to be on the same page about. And a competition is, let's say, let me write those things down. What exactly is a competition? Just give me a minute. Yeah, now it works. So let me write what exactly is a competition somewhere here. So competition is, let's say, 90-minute coding challenge. Leaderboard, there are two criteria to define the leaderboard in the ascending order. Descending order rather, not ascending order, descending order of priority. The first is number of problems solved. And for now we are assuming that all the problems are of the same type, they are of the same level. There is no different marks for each problem, though if there are, then we can manage that as well easily. It's not that big a deal. But for now, let's assume that there are 10 problems in a competition in a 90-minute thing, and each problem contains equal number of scores. So by that particular situation, the person who has solved the maximum number of problems is top of the leaderboard. However, in the situations where two people have solved the same number of problems at the same at any given point in time, then what we will do is we will use the submission time in order to define or decide who is the leader among these people. And the third part is, let's say there are 100k active users in parallel. Okay, so these are this is what defines a competition. And one way to figure out how to get this leaderboard is we'll do a get query here. Then so this is, I forgot to add here, post submission ID. This is again problem ID, and then leaderboard. This is comp ID. I should add PID here so that we do not make a mistake in remembering. Okay, and then we are having the same things here as well. Okay, whatever. So we will do a query on this particular database for a given submission, and then we can get back the data for the leaderboard. And then we will be polling the leaderboard from the client every 5 seconds. Now this can work, of course, and let's leave it there. This is a working solution, and we would want to come back to this in our non-functional requirements. So which comes up with our fourth non-functional requirements, which is faster let's say faster faster is not good, so fast response time for leaderboard queries. Fast could be, let's say, real time, and real time is defined by, let's say, within 5 seconds, as in, like, we do not want our system to be super fast like an Uber system where we are constantly told how many meters a particular driver has traveled the distance while coming to my location or even during the transit. So we do not want that kind of second level or millisecond kind of granularity, but at least somewhere in the vicinity of 2 to 5 seconds, in our case 5 seconds, should be good enough. Cool, so that is a non-functional requirement, and with this particular API request, our functional requirements are satisfied. Now we can move to our non-functional requirements. So run the code in an isolated environment to ensure security. This is almost done. It's almost done. We are using Dockers to ensure this. However, there are a couple of other things which we can use to ensure that there is no way a malicious code can run inside the container and have unwanted results. So let's talk about that. This is using Docker to ensure other Docker features, using Docker to ensure secure environment for code execution. So the first thing is we can use we can have network restrictions that the outbound solutions, outbound requests, outbound connections could be only to this particular machine or this particular port, or yeah. So network restrictions. The second is we can have, there's a command called seccomp. I think it's seccomp, sorry, yeah. So it is seccomp, which allows, or rather which blocks a lot of system calls on your container. So I was looking at seccomp earlier in the day, and you have to have that kind of configuration when setting up the Docker. After you have set up the Docker, you cannot enable this. But as I read, apparently it blocks maybe around 44 of the system calls out of 300 plus, or it enables 44 out of 300 plus. Point being, long story short, whatever be the case, it blocks a lot of system calls, and in this particular way we can secure our containers. We can make sure that there is no malicious code, no system calls are executed inside the container. So stop or restrict system calls from the container. Then there could be a time window, so time restriction. You can have, there could be an infinite loop which the user inadvertently or advertently as well, intentionally as well, adds to the code. And if that is the case, then our particular Docker and hence the underlying resources are blocked forever, which is again not a good use case. So we can have a time restriction that if the code executes for more than 5 seconds or 10 seconds, we will just kill that particular execution. So time execution, kill the container if code executes for more than 5 seconds. Similarly, we can have CPU memory restrictions as well. If the container exceeds a certain limit, if the memory usage by the code executes certain limit, then we will kill the machine, kill the container if predefined limits or thresholds are breached. And the fifth thing is that we set this system as only a read-only system, in the sense that our code cannot write to the system, the container, but it can write only to a temp directory, and that temp directory is deleted every 5 to 7 seconds. Every new or every execution of a container, we delete the temp directory. So read only system write to temp directory. Cool. So this takes care of the first requirement, first non-functional requirement, which is run the code in isolated environment to ensure security. Now supporting a peak of 100,000 users during competition. This could be done through either horizontal scaling, pretty straightforward, or the other thing is like, if we are talking solely about the competitions, assuming that this is not about competition, then obviously horizontal scaling will work. And I'll come to the queue thing in a while, but just horizontal scaling should work. However, if you're talking about competitions where we can anticipate that the load will increase on a system, then we can proactively set up a situation where we have we have created some extra instances which are sitting idle before the start of the competition. Let's say a minute or 2 or 5 minutes before the start of the competition, and then these particular nodes could be used throughout the 90-minute competition, and then once the competition is over, then we can terminate these nodes. So in this situation, we will have an alternative approach where we are not necessarily using auto scaling, but we are anyway horizontally scaling a system. So that is one way. The other way is, of course, we have auto scaling. However, this was only about competition. What if there is a genuinely sudden peak of submissions for whatever reason? On the new year, every coder wakes up and decides to start using LeetCode very rigorously, very religiously, and then there are n number of submissions day and night. So in this particular case, obviously horizontal scaling will work, but we can also have a queue added to our system such that any new request for a submission would first be added to the queue, and then our workers down the line will pick up these particular submissions from the queue. They'll execute, and then they will return back the solution. Now, having different workers and a queue also ensures that if any particular node or any particular container goes down, then we do not lose the progress or lose the code submitted by a given user. We can spin up new instances, or already existing new instances can pick that particular message from the queue, and then they can execute and then give back the result to the user. There would be some delay. The user might be expecting the data to be given to him or her in, let's say, 5 seconds, and we take 2 extra seconds. But that is reasonable given that that is going to happen only once in a while. So that is the other thing we are going to add here. Let me move these 2 things somewhere else. Okay, and we will have to add 2 things here. One is the queue, and we can use any queue. We can use SQS, we can use Apache, Kafka, anything would work. Doesn't make any much difference. So Apache, Kafka, AWS, SQS, both will work. Queue submissions. Okay, and then the other thing we'll have is a worker, and then we will have all these submissions, all these containers running inside the worker. So this, and then your worker will write back response back to the API server, and then it will write back to database. Now, obviously, we could have used the worker itself to write to database, but we do not want to have a connection between worker and the local database, LeetCode database. We want to have those two things separated out. Cool. So that takes care of the second part, the support for 100,000 users using competitions. Availability is greater than consistency is taken care of by redundancy. We'll have horizontal scaling. We'll ensure that the system does never go down, and that will take care of our availability higher than consistency as well. The fourth thing is response time should be less than 5 seconds. We should have real-time response for leaderboard queries. This is a kind of a good tricky part. Earlier we have a SQL query running here itself, and this does all the complex aggregations. It does all the range queries and so on and so forth. But the problem is that if there are so many users, they can hit the database and it could overburden. Also, it is not as fast. Our Postgres, we'll have to very smartly configure Postgres to handle that query. But again, every query, let's say different queries are coming every 1 second, every 2 seconds, every 30 seconds, every 0.5, every 500 milliseconds. So there would be a lot of querying, and that might overload the system. That is not optimal. What we can do instead is use this thing, a Redis thing. So we will have a Redis. What is it called? Redis cache. And the other thing we can have is a cron job. So a cron job runs this query, let's say every 5 seconds. Run query every 5 seconds. Okay. It saves that particular data on this Redis, and then we make a request to this Redis to get the leadership data. Okay, so this might work. This is a fairly okay solution, but there is a better solution here, because every query again is going to have a load on our database. That is not great. It's not ideal. So what we can do instead is this: we can remove this cron job, and whenever there is a submission on this API server, we will do a couple of things. One, we will fetch the data of that particular user. We'll do these computations where to figure out what exactly is the score of this particular user. We'll have this logic where we are incorporating the number of submissions by the user, the successful submissions, and also we are talking about we are taking into account the time, the average time, or the collective time this user has taken to submit n number of different solutions. So by using that formula, we can figure out what exactly is the score of this particular user, and then we can put that particular score in Redis. How we will do that? There is something known as sorted set in Redis, and I have to read a bit more about it. There is again an article by Hello Interview doing a deep dive of Redis itself, which has a sorted set section. But from whatever I read while looking into this particular problem, the way it works is that it has a key which works as the sort key. So by that sort key, we can define the system, we can define the entire data in a descending or ascending order. Now that sort key could be the score, which is calculated at the API server whenever a user submits a whenever you submit a solution and that solution is successful. So that part is important. So it will not happen, the calculation will not happen when the user makes this post submission request. It will happen when the worker gives back the solution with the status of whether that particular solution submission was successful or not. If it is successful, then we will make those calculations and we will store that particular data in Redis. And now, because we are doing that particular query from Redis, it will be very fast given that it's in memory, and then we can give back the result to the user very quickly. And then at the user end, we can have a polling of, let's say, every 5 seconds or 2 seconds, whatever works best. The client can poll the API server, and from API server we can query Redis cache. We can figure out the leaderboard in that particular state, and then we can give back to the user. Of course, this get call will be parameterized. There would be a page nation thing there, which I forgot to add here, so let me just add it. So we'll have page equals to 1 and %items equals to 100. So this will be useful in the case I want to get the number of items from, or the leaders from 500 to 600. So I will just do that kind of request at Redis, and it will be able to give me that result in a very quick manner. A repetition of what solution, what data structure we'll be using sorted set in this particular case to keep a track of the leaderboard. Okay. Now this supports all the non-functional requirements. One thing which was again mentioned on that particular article and in the corresponding video as well is talking about how we are going to run the test cases, which is an important question. We can obviously the novice, the brute force answer is that we will have test cases for each and every language, and then they would be executed in the container. That works, but then managing all those test cases would be a nightmare. Let's say I add a test case in Python, I'll have to make sure as an admin to add the same test cases for the other two languages I'm supporting as well, and that is very manual, not a great solution. The alternate solution is to use some kind of a harness to run test cases. So what exactly that means is that we will have test cases, one test case or one set of test cases for the entire problem. The test cases are not language specific, they are problem specific. And then so the test case will have, let's say, a set of input, a set of output, which would be serialized, and then we'll have a test harness written in each language. This test harness, this overall structure will deserialize the data, the input and output for this particular test case, and then it will compare, it will run the test case given this input, and then it will compare the output with the expected output which was deserialized. If it passes, then it's great. If it does not, then obviously it's a failure. So in this situation, in this scenario, one harness for each language will work. And again, we can have just, if you have 5 different languages supported, we can have 5 harnesses, and then for each problem we'll have different test cases. But these test cases are global, these are not language specific. So in that scenario, in that way, we can ensure that we are not writing or managing or maintaining other test cases for each language for each problems. We just want to maintain test cases for one particular language, for one particular problem. Then they could be 500, they could be 100, they could be 50, whatever. Cool. So that was the system design for LeetCode, and I guess we have covered everything. Let me just go back to the article ones and make sure that I'm not missing out on anything, so that if I'm missing out, I will ensure that I do remember that as the time progresses. So these are out of the scope, functional requirements, social features and whatnot. We have payments here, so that is okay. but social features are not, it's fine. Okay, okay. And then fault tolerant, secure transactions, CI/CD. Okay, it's fine. Okay, system interface. Okay, okay. High level design. So as I mentioned earlier, they have used NoSQL database. I went ahead with a SQL database. I did not talk about explicitly, but they would be, in problems we'll have. Okay, so I have test cases there, which is great. I did not miss it out. Okay, given problem code solution, we have Monaco editor. It's fine. Then submit the solution, API server, VM, Docker, and serverless function. I did not talk about this, but I think it's fine. We could have used a Lambda kind of thing as well. This particular solution is good enough. Then leaderboard competition, we talked about this as well. So this is the query which we would be using. I did not specify the query here, but it's a reasonably, not reasonably, it's not a very complex query, but I mean, it is going to take some time. Cool. Then potential deep dives, we talked about these things, isolation, okay, fetching the leaderboard more efficient. We talked about polling with database queries, caching, and Redis sorted set, and system scale to 1,000 users, vertical scaling, dynamic scaling, and horizontal scaling with queue. Okay, we talked about this as well. And this is the harness thing, the test case thing which I talked about. So cool, this is it. And the last thing which I was talking about is the Redis thing here. If we search for sorted set in this particular data, in this particular article, we have this. Sorry, my bad, not this one. Sorted set. Yeah. So this is it, and then there is this document which I looked into, which gives an example of how this would be used. So there is a range query. So let's say this is from -infinity to 10, but I can obviously change this from, let's say, 1 to 5 or whatever. So in this situation, this can work as well. I think that's all for the LeetCode. That's all for the LeetCode system design. We are good here, and I can end this video. Cool. Okay, thanks for watching. Bye bye.